Hey there students, so in this clip we're going to be going over how to graph ellipses in general form. So let's write down the title of the notes. Graphing ellipses. And then we're going to be focusing on the general form um, of the equation. Okay, so general form. Alright, let's write down the instructions for the examples, and then we're going to go ahead and go over two examples. Alright, so the instructions as follows. Um, for the given equation, for the given equation of an ellipse, express express it in standard form, and find the center, direction of axis, C of the foci, and eccentricity. And then after that, graph and label completely. Um, completely stating the foci and vertices on the side. Okay, so after doing all this, I want you to conclude by stating what the meaning. So basically state the meaning of your result. Okay, all right, so let's go ahead and take a look at example one. So for example one, we have the equation 16x squared plus 4y squared minus 64x plus 24y plus 36 equals 0. Okay, so to get started, what we have to do is this is basically the general form of the equation of an ellipse. This is the general form. So what we're going to do is we're going to put this in standard form, because standard form basically makes it easy to tell the information that we need to. Let's go ahead and do that. So to do that, what I'm going to do first is place the x's together, the y's together. So I'm going to have 16x squared and minus 64x. These are the x's together, and then plus 4y squared plus 24y. Alright, I just brought the 4y over here. See, this 36 is neither an x nor a y, so I'm just going to move it over to the other side. So I'll subtract 36 from both sides. And then it's going to be equal to negative 36. Alright, now I'm going to deviate along the center. What I'm going to attempt to do is I want to create two perfect square trinomials, one in terms of x and the other in terms of y. But first thing I want to do is I have to make sure that this x squared is standing alone. So on the left side here, I'm going to factor out 16. Okay, so if I factor out 16 is as though I'm dividing these two by 16. So if I have 16 factored out, I'll be left with x squared, because 16, if I put 16 down here, it divides out, minus, if I divide this by 16, I'll get 4x. Okay, and on this side, I'm going to factor out a 4, because I don't need any coefficient with this y squared. So if I factor out a 4 is as well as dividing both sides by 4, so I'll be left with y squared plus 6y. Okay, now focus your attention in this quantities in the parentheses. I want to make them perfect square trinomials. Alright, so I need three terms The third term will make him a perfect square trinomial. Alright, so how do you do that? All you do is b over 2 square, right? That's the shortcut for creating perfect square trinomials, b over 2 square. So I'm going to do this for the x and the y. So b for the x is a coefficient right here because that's b for the x. B for the x is negative 4. What do I do with this? I divide it by 2, negative 2, and then I square it, 4. This term completes the square on the x side. And then on the y side, the b for the y is 6. I divide that by 2, which is 3. I square it, I get 9. Alright? So let's insert these terms that complete the square in both worlds. So I'm going to have 16 times x squared minus 4x. And now I'm going to just add in that 4 plus 4. And then on the y side, I'm going to have plus 4 y squared plus 6y. And then I'm going to add that 9, okay? Plus 9. Alright, now this is where you have to be really careful. On the right side, what is it that we're going to add on the right side of the equation? Minus 36. So what do we add here? You notice I added a 4 here, but do I add a 4 on this side though? Since I added a 4, but wait a minute, there's a 16 here. So what I'm going to add here, instead of just 4, is going to be 16 times 4. Okay, so I'm going to put that in red. So let me erase that first. Let me probably move it. So I'm going to be multiplying. I'm going to be doing adding 4 times 16. Let me put a dot here, a dot here. Okay, 4 times 16, so it's going to be 16 times 4 instead of just the 4. Okay, and then on the y side we have a 4, and then we have a 9. So I'm going to be multiplying here by 4 times 9. Okay, so that's basically how it's going to be. Alright, so now what I'm going to do, I'm going to factor the left side, and then because we already have a perfect square trinomial, so on the left side I'll bring down a 16, and what you do is I root the first and the last. I root this, put that in red. I root the first term, and I root the last term, and then I just bring down the middle sign. Okay, so this one is going to be x minus 2 quantity square plus, bring down this 4, same story here, you root the first and the last, bring down the middle sign, so I root this, and I root that, and I bring down the middle sign, okay? So you're going to have on the y side, y plus 3 quantity square. And here we're going to have negative 36 plus 16 times 4 is 64 plus 36, so we'll be left with 64. So here we're going to have 16 times x minus 2 square plus 4 times y plus 3 square equals, see this 16, negative 36 and 36, they're opposites, so they cancel out. So you're left with 64. Alright? Now I don't need any coefficients in front of my quantity square because we know the standard form of an ellipse doesn't have anything in front. So I'm going to, and it's also equal to 1. So what I'll do is I'll divide both sides by 64. The reason I'm doing that is I want my equation to be equal to 1. Alright? So let's work this out. On the left side, 16 goes into 64 4 times. So we're going to have x minus 2 square over 4, because 16 goes here once, and then 16 goes here 4 times. Okay? Plus, then we'll have y plus 3 square. 4 goes into 64 16 times, right? Equals 1, because 4 goes here once and 4 goes here 16. Okay, so just by reduction. Alright, now that we have this, we now have it. This is the vertex form, the standard form I was asking for. Alright, so we have part of the problem taken care of. So this is a standard formulation of the equation of an ellipse. Now, what we're going to do next is find the information that I asked for. Alright, so let's go ahead and find those. The first thing I need is the center. So let's write that. So the center is as follows. Center of the ellipse is, we do the negative of what, or the opposite of the x and the y's coordinate. So opposite of 2 is 2, and opposite of 3 is negative 3. So there goes your center. And then axis. I'm going to call this the semi-axis, okay, because we're doing half of it. So for the axis, I'm going to do square root of 4, which is 2. Since it's under the x and the x-axis goes side to side, this would be 2 units side to side. And this should be your minor axis, right? Minor, because it's going to be smaller than that. So when you square root 16, which is a number under the y, you're going to have 4. And that's up and down. This is going to be a major. Okay, the bigger one is a major, the smaller one is a minor. So this is a semi-minor axis, and this is a semi-major axis. Those are the lengths, all right? Now we need a C for the foci, C for the foci. So all you do here is just you do the C equals the square root of, remember there's a plus here, so you subtract the bigger one from the smaller one, 16 minus 4, which is going to be the square root of 12, and that reduces to, if you work it out, for 12, 2 times 6, 2 times 3, and then these two come out as 2. So 12 is basically 2 root 3, right? So this becomes 2 root 3. In order to be able to graph this, 2 root 3 is approximately 3.46, or let's just say 3.5. And this is going to be going in the direction of the major, so it's going to be going up and down. Okay, when we're graphing it, we're going to be going 3.5 units up and down. Alright, so let's do the eccentricity. So the eccentricity is how stretched out our ellipse is. Eccentricity. It's going to be stretched out up and down, obviously, because that's the direction of the C. So to find the eccentricity, you're just going to do C divided by and the major axis, semi-major axis to be specific, semi-major axis. So our C is 2 root 3, and then our semi-major axis is this one right here over 4. Okay, so I can divide these 2 by 2, so I'm going to have root 3 divided by 2. Okay, so that's basically the eccentricity of my ellipse. All right, so let's see how close to 1 is that, just to give you an idea of what that means. So if I do square root of 3, square root of 3 divided by 2 is 0.866. So it's not too stretched out. The closer it is to 1, the closer it is to a circle. The farther it is from 1, the farther it is from a circle. Okay, so it's 0.866. All right, so let's do that. Let's write that down. So it's approximately 0.866. All right, so there goes your eccentricity. Now that's all I need for the properties of the ellipse. Now let's go into the graph. Generate the graph. Now you notice that we have a center is in 2, -3, so we're going to go to the right and down. So our ellipse is going to be centered in quadrant 4. All right, so let's go ahead and create our coordinate system, taking that into consideration. I'm going to shift my y-axis to the left a little bit, and then I'm going to shift my x-axis up. All right, so let's grab the center. The center is 2, -3. 2, -3. So let's graph that. Center is going to be 1, 2, and -3, 1, 1, 2, 3. Okay, so everybody go ahead and graph the center. Now we're going to go up, down 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. There goes our vertices. And then we're going to go side to side 2. 1, 2. 1, 2. And there goes our co-vertices. Okay? So let's connect the dots as best as we can. Draw a nice ellipse. Take that. Oh, I'm kind of missing the point a little bit. But yeah. So and then yeah, like that. Alright, so there goes your ellipse. So now let's go ahead and label it. This right here, this is a vertex. To make my life easier, let me label what the center is. Okay, so the center is 2, -3. So the vertex, I'm going up 4 units, so I just add 4 to my y-axis. So it's going to be 2, 1. So my vertex, one of my vertices is 2, 1. Alright. And then I also have a vertex down here, which is also a vertex. I'm going 4 units down from this, so it's going to be 2, -7. And also along this axis, the major axis, we have our foci, which is 3.5 units up and down. So I'm going to go 1, 2, 3.5 right there. I'm going to call that F1. And since I went 3.5 units up, I'll just add 3.5 to that. So it's going to be 2, 0.5. Okay. And then going down 3.5 units. This is going to be F2. Second foci is going to be 2, and then we're going down 3.5 units here, so it's going to be 6.5. Actually, -6.5. All right, because we're subtracting. All right. So this whole thing that we're putting all this information on, that's the major axis, and this right here is the minor axis. All right, I'm going to label that in a minute. But before we do that, I want us to label this. This is known as a co-vertex. That's the main vertex right there. This is a co-vertex. So this co-vertex, we're going 2 units to the right, so we add 2 to the x. So we're going to have 4, -3. And this is the other co-vertex right there. So since we're going 2 units to the left from 2 through, we're subtracting 2 from the x coordinate. Or you can just count, and this is basically 0, -3. Alright? Now this axis right here, that is the major axis, and the length is 8, because you're going 4 units up and down. And then down here we have the minor axis, and the length is, since you're going 2 directions, 2 units side to side, is going to be 4 units. Okay. Alright, so that basically is all the information I need. But on the side here, the 2 relevant information that are normally asked for in the graph is the foci. So the foci are basically your F1 and F2. So the foci are 2, -6.5 and 2, 0.5. And then the vertices are just your vertex. Vertices. Vertices are 2, -7. This one right here is one vertex, and then the other one is 2, 1. The co-vertices don't really count for this information. Yeah. All right. So we have that done. Now let's write down what on earth does all this mean. Okay. So the meaning is as follows. The meaning basically is that if the locus of points whose sum of distance from 2 fixed points, the 2 fixed points here are going to be your foci from 2 fixed points to -6.5 and 2, 0.5 is constantly what? the length of the major axis is constantly 8. Okay, that's the major axis. Keep that in mind. It's constantly 8. Then the ellipse has the equation 16x squared plus 4y squared minus 64x plus 24y plus 36 equals 0. So basically, if you have the locus of points with some distance from two fixed points is a constant, gives you an ellipse. So we just put that information here and then just create ourselves what this whole result actually means. Okay, so this is the meaning. All right, that's that. Now let's take a look at example number 2. We're going to do exactly the same process. So let's write down the question for number 2. So for number 2, we have the equation 25x squared plus 150x. Let me write this one. Let's write it this way. Let's go 25x squared plus 16y squared. Sorry about that. Plus 150x minus 64y minus 111 equals 0. So let's put this in standard form first. This is a general form. Okay, so keep that in mind, general form. So what I'm going to do is I'm going to put this in standard form. So to do that, first thing we'll do is we'll collect the x's and the y's. So I'm going to have 25x squared plus 150x. Alright, and then the y's plus 16y squared minus 64y. Now this 111 right here, I'm going to move it over to the right side. So I'm going to add 111 to both sides. Because 111 is neither an x nor a y. It's not a variable, it's a constant, okay? So it equals 111. Alright, now let's split them along down the center because I want to complete the square in both worlds. So remember, I want to have the squares clean. I don't need any coefficients with them. So I need to factor out this 25 right here and this 16 right here. So let's do this first. If I factor out a 25, let's do all dividing. So I'm left with x squared plus 6 plus 6x. Okay, please don't factor out the x's, just the coefficient. That's all you factor out. Okay, and on the right side here, you take out 16 and you have y squared minus 4y. Okay, equals 111. The goal here again is just to make sure that the squares are by themselves, so we can complete the square with less issue. I mean, with not much complexity. Okay. All right. So let's do this. So to complete the square in the x world, we just need b of x. B of x, that's b right there, 6. So what do we do with it? Divide it by 2 and square it, 9. That inserted here makes this a perfect square trinomial. In the y world, we have negative 4. Divide that by 2. You have negative 2. You square that, you have 4. Insert that here, that gives you a perfect square trinomial for the y world. Okay? Now for the x world, we have 25 x squared plus 6x, and I'm going to insert that number right there, plus 9. And then on the y world, 16 y squared minus 4y, and I'm going to insert this number right here, plus 4, just to make it a perfect square trinomial, equals 111. Now, what do I add here? So we have to be really careful, because this is where people make most mistakes. Be careful what you add in here, okay? So I have 9, but not just a 9, there's a 25 in front right here. So I need to add the product of these two, so plus 25 times 9, plus, here you have a 4, but it's been multiplied by a 16 in the front of the parentheses. Upon distribution, what you add in here is actually 16 times 4, so here you have to put 16 times 4, alright? Okay, let's finish this off. So on this side, you just bring down to 25. I'm going to root this and root that and bring down the middle sign. It has a factoring treat for perfect square trinomial, so I'm going to have 25 times x plus 3 quantity squared plus, bring down to 16, do the same process here, root the first and the last, and bring down the middle sign. So it becomes y minus 2 quantity squared. And then when I add all this, I'm going to have 111 plus 225 plus 64. Okay? And then we're going to have 25 times x plus 3 squared plus 16 times y minus 2 squared equals, and if you add all this 9 years together, equals 400. Alright? Now remember that an ellipse in standard form is equal to 1, so I'm going to divide everything by 400, so I can have a 100, I can have a 1 on the right side. Okay, so divide this by 400, divide this by 400, and divide this by 400. Okay? Alright, so what does that yield? 25 goes into 416 times. Okay, so we're going to have x plus 3 square over 16. Why? Because 25 goes here once, and 25 goes here 16. Alright, plus 16 goes into 425 times. Alright, so on the right side we'll have y minus 2 quantity squared over 16 goes here once, and 16 goes here 25 times. Okay, I just said that. Okay, but 25 equals 1. Alright, yay, now we have our standard form. Okay, this is a standard form. Now, we're going to use this information to find the properties of the ellipse, graph, and then state the meaning. Alright, so first thing I'd like us to state is the center. Alright, what is the center of the ellipse? You do the opposite, so you're going to have negative 3 comma 2. That's the center. And then direction of axis, the semi-axis direction. Let me just direction of semi-axis, because we're just doing half of it, right? Semi-axis. Alright, so we're going to do the square root of 16, which is 4. That's going side to side, because that's the direction of the x-axis. And then the square root of 25, which is 5. That's going up and down, because that's what's under the y. Since this is smaller, it's the minor, semi-minor axis. And then this is bigger, so that's the major, semi-major axis. Remember, it's half, okay? Alright, now the C for the foci. C for the foci. So the C for the foci, basically what you do is you go either the square root of, since you have a plus here, you do the opposite. 25 minus, you do the bigger one minus the smaller one. And that gives you the square root of 9, which is 3. Since your major goes up and down, your foci is going to be going up and down also. 3 units up and down. Alright, eccentricity. How close is this ellipse to a circle? How close is it to 1? Eccentricity. Let's see. Eccentricity is basically C over the semi-major axis, the value, whatever that is. C is 3. Semi-major axis is 5. So that's basically what it is. 3 over 5. Okay? That's approximately, that basically equals 0.6. Alright? Okay, that's your eccentricity. Now that's all the information I need. Now let's go ahead and graph it. Alright, so the graph. So for the graph, what we're going to do here, let's see, find the center first. Since we're going 3 units to the left and 2 units up, our center is going to be centered in the second quadrant. All right, so we're going to the left and up. So let's make our second quadrant as big as possible. So I'm going to shift my y-axis to the right a little bit, and then I'm going to shift my my x-axis down. All right, so let's graph the center. So you're going to go 3 units to the left, 1, 2, 3. and then 2 units up, 1, 2. So there goes your center. Alright, to graph my major axis, I'll go 5 units up and down. 1, 2, 3, 4, 5. Semi-major, 1, 2, 3, 4, 5. Semi-major in the other direction. And then those are my vertices. Now to graph my co-vertices, I'll go 3 units side to side, actually 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Okay? Alright. With that in mind, just connect the dots, and that will be our ellipse. Okay, so let's go like that. Right there. Let's go like that. Okay? And then this one comes out. Oh gosh. And then, sorry about this. My ellipses are not coming out well today. Try again. So go like this. Through there. Just try the best as you can. Okay. All right. So there goes my horrible ellipse. Now I'm gonna go ahead and label. I want to draw my major axis first because that's a lot of things are going on here with my major axis. All right. So first thing I'm gonna do is I like to label the center because that's my point of orientation or reference point. So the center, my center is -3, 2. Alright, so from there going up to my vertex, the first vertex, the vertex is going to be -3, 7 because we're going 5 units up from here. Okay, and then also down here is my other vertex. So we go down 5 units from there, so that's going to take us to -3, -3. And then I want to graph my foci while we're at it. So we're going to go 1, 2, 3, go up 3 units, right? So that's going to be F1. This one right here, F1. F1 is going to be -3, 5. F2, you're going to go down 3 units, 1, 2, 3. And this right here is F2. And F2 is going to be -3, -1. Okay? Now let's go ahead and label our co-vertex. So this point right here is your co-vertex. Your co-vertex is we're going 4 units to the right, so it's going to be 1, 2, 3, 4, right? So it's going to be 1, 2 from the center. This is your other co-vertex. This co-vertex right here is going to be 4 units to the left from the center, so that's going to be -7 plus 2 because you just minus 4 from this one right here. That gives you that. All right. So there you have it. Now let's label our axis and their lengths. This right here, this axis right here is your major axis. Major axis. Okay, because it's a longer one, and the length is 4, 5 plus 5. The length is 10. Okay, so the length, pardon my H, the length of my major axis is 10, and this right here is your minor axis, and the length is going to be 4 plus 4, which is 8. Alright, so what does all this mean? Well, let me just state my relevant information here. Just state the foci. You just have to state the foci. So the foci is -3, 5, and -3, -1. And my vertices are -3, -3, and -3, 7. Okay. All right. So let's write down what all this means. So the meaning are as follows. So meaning, if the locus of points, whose sum of distance from two fixed points from two fixed points. The fixed points are your foci from two fixed points, namely -3, 5, and -3, -1. If the locus of points whose sum of distance from two fixed points, -3, 5, and -3, 1, is constantly the major axis, which is 10, is constantly 10, then the equation of the ellipse is given by the original equation, which is 25x squared plus 16y squared plus 150x plus minus 64y minus 111 equals 0. So basically that's it. That's what this whole story means. All right. So thank you so much for paying attention to this video. You can always subscribe to my videos on YouTube and request videos if you need help with anything. And also the collection of my clips can be found at madgoodsurf.com. Alright? So have a wonderful day.